Good day, viewers. You are welcome back to my YouTube channel. If today is your very first time chancing on this YouTube channel, make sure you subscribe, turn on your post notification, watch this video to an end, and then benefit and then appreciate what we mean by the difference quotient. Viewers, note that we've already premised with functions. So whatever we do here, we will use the functions in order to appreciate the what? The difference quotient, all right? Now, let's say a variable, or when you have a variable, say x, and then this variable, which is an input, all right, is an input, changes from an initial point, let's say x0, to a new point, x1. If you want to find the difference, we take the new value of the x or of the input, x1, and then we subtract our old value, which is x0 from it.
The change.
All right. So now, viewers, by representation, if you want to represent the change, we represent it by the what? By the delta sign. All right. So viewers, if you want to find the change in x, which is the input, we have the what? The change of x being equal to the what? The new value of the what? Of the input minus the old value of the input or of the x, all right? So this now gives the difference in what? In the input. So viewers, note that wherever you see f of x, what we mean is the value of the function when the input is x. So what it means is that when we have f of x naught, it means the value of the function, and then also when we have f of x1, it means the value of the function at a what? At a new point. All right. So now, if you want to find the difference in the change of x, then we have what? The change of f of x will give us what? The f of x at a new point. The f of x at a new point minus the f of x at the old point. All right. So this is how we find the difference of what? Of the input. So viewers, note that by this we say that, or when you see f of x, it doesn't mean this. This f of x and then x are two different things altogether. All right. So this is the what? The input, and then by evaluating the input, you get a what? The output, or it gives the output. All right. So note that this is the input, and then also this is the output. So if you might come across something like this, xi or x subscript I. This does not mean x. All right. This xi represents a chosen value. A chosen value of x. So let's say if we have x to be 1, 2, 3, we can name this to be xi, this to be xi, and then this also to be xi. So the xi basically means that what? A chosen value of x. So if you have your function to be what? To be f of x.
Good.
And then you are assuming xi equals 1, and then you are to what? To find your f of xi. What it means is that you should substitute this into the function. So you can have something like f of 1, and then you find your value. All right. So that is basically what xi or x subscript I means. Don't see this and then term it as x. All right. This is a chosen value of x, not x. So viewers, so get the difference. Let's take an example to appreciate the already established formulas or what we've explained earlier on. All right. So now the example reads f of x equals 5 plus x squared. Find the value of x when x equals 0. Sorry, find the value of f of x when x equals 0, and then x equals 2. All right. So now by solution, we already know from functions that f of x is y. All right. So that means f of x, which is y, is the same as what? The output. And then we have what? Our x to be our input. So what we want to find is when we input our value, or when we input this into the function, what will be our output? Alright. And then we've seen that the xi or x subscript I is what? Is a chosen value of x. So we can say that I, the chosen value of x, is what? Is 0. Alright. So if we have our function to be f of x I, what it means is that we can input 0 into the function to find our f of x. So we have our 5 plus x squared, right? And then we have the chosen value to be 0. So we have f of 0 to be 5 to be what? 5 plus 0 squared. And then, as we all know, this squared will give 0. So we have our f of x, or our y, to be what? To be 5. Alright? And then also, when we have our x of I, or the chosen value of x to be what? To be 2, then if we input that into the function, and then we have f of xi equals 5 plus x squared, then we will have what? F of 2 to be what? To be 5 plus 2 squared. So therefore, our y, or our f of x, will now give us what? 9. Alright, so now we've already seen that this is our output. So when input was 0, our output was 5. And then also when input was 2, our output was 9. So since we have our 2 outputs, so you can see that based on the function we've seen earlier, it is helping us to establish or to generate our output. Alright, now with all of this, we want to look at what? The difference quotient. But then we want to establish the basis before we move on to the what? To the difference quotient. Now, as we've seen, we want to what? Establish the what? The difference quotient. So you can see that when x changes to a new value, x1, since our output is based on the what? The input, then it also means that our output should also change from what? From f of x to what? To a new output, which is what? Which is f of x naught to plus what? The change in x. Alright, because we already have what? The f of the x naught changing to what? To a new value. So the difference is what we are telling us what? The change in x. Because let's say if we have 1 and then 1 changes to 3, the difference between 1 and 2, 1 and 3 is what? Is 2. Alright, so if we want to get the new value, which is 3, if we want to know how we got the 3, then it means that we have to add the change to the initial value to get the new value. So that is the main reason why we have what? The f of x naught, which is the output, the initial output, changing to what? To a new output, which is what? F of x naught plus the change in x. Alright, so based on this, we can say that the difference quotient is what? The change in y over the change in x will now give us what? We know all this is for y, alright? And then this is the new value of y, and then this is the initial value of y. So the change in y will be what? The new value minus the old value. So we have f of x naught plus the change in x minus the initial value, which is what? F of x naught. Alright? All over what? The change in x. Right? So basically, this is what? The difference quotient. Or all what we did boiled down to what? To the difference quotient, which is this formula. So moving forward, this is the formula we'll be using to what? To examine ourselves or to solve examples. Alright? In order to what? To appreciate the difference quotient. And then we've already seen that the difference quotient is the what? Is the average change. It's not the actual or the true change, alright? It's the average change. Moving forward, we'll look at the what? The true change during what? Derivative. Alright? So based on this, we will leave the what? The formula, and then in our next or subsequent videos, we will look at what, or we will appreciate examples in order to understand the difference quotient.